So for introductions, I am Rob Cannon. I'm the FNL program manager. Connie Engberg is our amazing project support assistant. We have Frank Noble and Bob Justice from Tripoli Rocket Association with us here tonight. And then Aaron Ashley is on the line right now with us. He's one of our instructors for the evening. Adrian is also on. He's one of the CRL assistants. And then Sean Osserman hopefully will be joining us shortly. He's playing it internationally. He's on a work trip, so it's going to be a little bit fun for him, the little time difference. If you guys would like, feel free to just take a few moments right now and then go around the room, virtual room, and then with our faculty and student introduction side. So I don't know who wants to start, unless you guys want me to call on somebody. Abigail, you want to go first?
Hello. Okay. You mute? Yeah. Okay, sorry.
No worries.
My name is Abigail Rigner. I am a student at Rochester Institute of Technology, studying mechanical engineering. I have pretty much no rocket experience, and my goals and expectations are just to learn more about building rockets.
Thank you. Montana Tech, do you guys want to go next?
Do you want me just to call out a name?
Sure.
Okay. So since we had Abigail, how about if we have Justin, who's also with RIT?
Hello, I'm Justin Tebbett, and I have little to no experience with rockets, and I really hope to just gain some good information and learn a lot through this workshop.
Thanks, Justin. How about Haskell next?
Hi, I'm Andrew Nolene at Haskell Indian Nations University, and this is our first year competing as a team when in the First Nations launch.
Hello, I'm Piquas Hernandez. I'm also here at Haskell. This is my first time building a rocket. Yes.
Okay.
I'm Ayana Tana, our team lead, and I'm just here for moral support.
Oh, great. Great, thank you. Montana Tech?
Can you guys hear us?
Yes.
My name is Aurora Beasley. I've got two screens over here. And I am a freshman mechanical engineer, and I have zero rocket experience, and I'm the team lead for our branch. And I'm super excited to start this, and I really hope to get a good grasp of rocketry in this workshop.
Hi, I'm Scott Kogel. I'm a lab director for mechanical engineering. My experience with rockets are Estes, nothing bigger than a C. So this looks really exciting.
Great, thank you guys. United Tribes.
Hi, can you hear us okay?
Yes.
I don't know if you can see me. I'm Kiana Stroh. I'm the team lead for us here at United Tribes. I have zero experience with rockets.
I'm Dominique Miner. I'm in the pre-engineering program. I have zero experience with rockets as well, and I hope to learn some information about it with this workshop.
I'm Finn. I have zero experience. I'm just the person that plays around with rock sims, I guess.
Okay, great, thank you. Jacob,
Hello? Is my thing working? I think it is.
yeah, we hear you.
Okay. My name is Jacob Catanzaro. I'm going for environmental engineering. I have no rocket experience and I hope to learn some about build rockets and learning some about them.
Great, and you're from University of North Carolina. Pembroke.
Pembroke. Yeah.
And also Daniel, also from the same school.
Oh yeah, I'm Daniel. I'm at UNCP. This is the first time building a rocket, and I'm a chemistry student and a physics student.
Okay, thank you. William from Seattle.
Hi, my name is William, and I study mechanical engineering, and I'm excited to build my first Level 1 rocket kit.
Thanks, William. And Nick from Turtle Mountain.
I'm Nick Dion from Turtle Mountain Community College. I'm currently pursuing an Associates of Science in Engineering. I don't really have any experience with high power rocketry, but I built like, the little rail launched model rockets before. So, and I just hope to really get to understand what's going on with these and like what the different parts are and stuff like that. So I can better understand my teammates when they're talking about what they're doing.
You'll definitely get that in this workshop. Great. Rob, do you want to have the different team members introduce themselves at all? Like Sean or Aaron or anything?
Yeah.
Bob, why don't you start? I see you first. Bob, can you get your mute off so that you can?
Yeah. Okay. What was the question? I'm sorry.
You're on. Just introduce yourself. Why are you a part of this?
Okay. My name is Bob Justice. I've been with rocketry for a very, very long time. I'm the prefect for Chicago and also part of the Tripoli, Wisconsin Association. And I enjoy working with the students, learning how to build rockets and how to fly them.
Great. Thanks, Bob. Frank?
Good afternoon or good evening, everyone. Frank Noble here, president of Tripoli, Wisconsin. With my team, they do quite a very fine job. I'm proud of them. We organize monthly launches every month for the past, like Bob said, forever. I've been with the FNL since its existence, and it's been a lot of fun. I enjoy it.
Thanks, Frank. Aaron?
Hey, all. I'm a system engineer at Raytheon in Tucson, Arizona. I'm from Nebraska. I'm Omaha and Ponte Dakota tribes. I was a student participant in FNL as a grad student at CU Boulder in 2018, and I've been involved with FNL for about the past 4 years, helping teach and run and judge things as I can. And I've been doing model rockets since like middle schoolish, and then high power rockets in college. And it is, yeah, that's about it.
Thanks, Aaron. Adrian is our backup. Since Sean is overseas, we're not sure if this is all going to work out. So Adrian, do you want to introduce yourself?
Yeah, my name is Adrian Gaither. I work as a mechanical engineer, non-aerospace. I've been in rocketry since I was in high school, which is over a decade now, and I've competed in various competitions. FNL was not one of them, but I did CRL, which happens at the same time. So yeah, that's me.
Thanks, Adrian. It looks like Sean has audio now. Sean?
Hey, how's it going, everyone? Can you hear me coming through?
Yeah.
Yes.
Okay, hey. We're doing introductions right now, is that right?
Yes, you're introducing yourself.
Sounds good. Hi, everyone. My name is Sean Osserman. Been helping out with this for the last 4 years now. I've been working as a mechanical engineer for the Boeing company for the last 5 years now. If it looks really bright outside, it's because it is. Right now I'm in Taipei, Taiwan. So the time difference here is a little crazy, but I'm happy to support and helping you guys build a rocket. So really happy to be here. Thanks for having me.
Thanks, Sean.
Thank you.
I think
Right.
everybody knows Rob and I, right? You're talking to us all the time. So I'm a project support assistant, and I talk to you and email you all the time.
Yep. And I just help. Pretty much at times feel like I'm helping Connie run this giant thing that we call a competition. But thank you all for joining us. So next. So as we go through the presentation, you'll notice some different colorations on there. As we go through, that'll just correspond to different sections, as it should correspond with handbooks references. If we have specific pages, we'll have them denoted in the bottom left. So that should help correspond to the handbooks that we sent out. And then additionally, we do have them available, the handbooks and the presentations, they're available on the website currently in the tips and trick area. So our schedule for tonight, I know it was sent out, but just a brief, we're going to be going through, you should have joined us for the supply kit overview. If not, hopefully you guys checked it. If you were the ones that got it late, hopefully all the parts were there, there are no issues. But we'll do a little bit of a RockSim intro. So you guys will be building your RockSim files as we go through the presentation, like through the whole build. So by the end of it, you'll actually, it should help you have a better understanding of how to build that as you guys are working on your competition rockets. Then of course, pre-fit check, overview build, get you guys working with some of the epoxy and then working on your motor mounts and that getting that build out of the way before Saturday. And then Saturday will be everything else. So as you see, it's a pretty tight schedule. Hopefully it won't be too much to take in, but everyone else has enjoyed it so far. Right. So as you saw, this is your coming in. So it is through Zoom. It is a little bit more challenging since we're not all in the same room. We can't just look over to your table easily. So as you're building, try to just make sure that your camera is on so we can see. And if we can, we'll try to gauge if you're like running into any issues. So it helps if you have a camera that can be directed, but if not, it's understandable. But it definitely will help for when we do any breakout sessions or breakout rooms. If you're running into any problems, we have, you know, Bob, Frank, Aaron, and Sean that we might be able to split out, and then you guys can work on things individually. So as we're going into builds is when we'll ask you to have your microphones on so we can actually just sort of open dialogue during those moments. But if it's during presentations and instruction, try to keep them muted so we don't have too much feedback. So as you see, we have our handbook. The references will again be on the left hand corner of the slide. We encourage you to take notes in the handbooks, write on them. It's your own to keep, so make whatever notes help you, you know, process the material. And as you see, we'll have different sections as we go through. Hopefully everyone has their RockSim installed and no more issues. I know we had some CD key issues before, but hopefully they were addressed by now. Anyone still having trouble with their program?
Yeah, I'm still having a little bit of trouble with my RockSim.
Okay.
It's downloaded, but for some reason, since I have a virtual machine on my computer, it won't let me run it.
Okay. Um, Aaron, do you have any thoughts on how to potentially troubleshoot that or no?
You run it on not the virtual machine.
I'm not running it on the virtual machine, but for some reason it detects that I have one on my computer, and I get an error saying that it doesn't want me to run it on a virtual machine, even though it's shut down.
Okay, that might have been more of an email to Apogee. I think my computer might have run into the same error. That would have been one to message them. It might be a little late, but if you can send an email to their support, they might be able to, like if they're open late potentially.
Okay, yeah, I already sent one yesterday, but I'll send a follow-up right now as well.
Okay. Yeah, they were pretty good before, but luckily with Abigail there, hopefully she'll let you look over as you follow along. But I had a similar problem. It's weird. And of course, as we have go through the build sections, we'll have our instructors to help you through it. And then you guys will be building at the same time as they are. So should help. So objectives for the workshop. This is to give you all the basic concepts to be able to build a high power rocket. This isn't a level 1 rocket, and it is directly, corresponds to the rockets you guys are building for the competition, let alone, any of the rockets that any of the companies that are launching to space. Same rocket design, just scaled up with different materials for like the walls and fins. Easy way to put it. So for this, where you're building, for this one, it's just going to be a basic level 1 kit from Lock Precision. I know it's named after Frank at this point, as we are thankful for his connection to Lock. So this will help you also go through RockSim. So it'll give you those basics understandings of the RockSim program and how to simulate it. And of course, the process for EEE level 1 certification. So we'll talk about that when we get closer to the end of the workshop tomorrow. So everyone has had a moment to go through all of their supplies. Frank, do you want to walk through it again, or?
I sure can. If anybody does not have the supply, speak out or give me a thumbs down. Let's see if I can see you on the camera here. Did you all receive a Launch to Learn handbook, I hope? And alcohol wipes and all to punch a hole. Craft sticks, you have about 15 of them. That's most important. Otherwise, you'll be using your fingers. You should have plastic cups to mix the epoxy in, and a plastic, not plastic, 18-inch wooden dowel. Yeah. 2 bottles of epoxy. One is a resin, one is a hardener. Nitro gloves. Masking tape. A paper plate, 2 of them, possibly, or just one. I don't know how many she sent. Looks like 2. Paper towels, you should have a bundle of them. A pencil, a ruler, probably clear like this, a clear ruler like this. 1 sheet of sandpaper, a small piece of sandpaper. A screwdriver set, you might have 1 screwdriver or 2. One's a Phillips, one's a flathead. I don't know how many you got, but we're going to be using the Phillips screwdriver. That's the one with the 4 points on it. Table covering, if you haven't done that now, I put it on your work space right now, your table covering, your plastic table covering, and a utility knife. Everybody have those supplies? If not, let me know. Okay, next slide. Okay, do we have another slide for this? All the parts that I sent? Is that in there? Oh, it's not. You don't have this then, huh?
No, I
Okay.
don't think that one's in. No.
right.
That one will be posted to the website. We'll get it
Okay.
posted.
I think we had a parts reveal parts last week, and I think everybody had them. Were the two schools that didn't get the kit yet? Is that correct, Connie? You're muted. Darn it.
Sorry, I was chatting with Aaron. What did you need?
Just two schools got their rocket late after the parts reveal.
Yeah, there were a couple people that did not come to the reveal, whether they had their rocket or not. Let's see. Gaskell, Aurora kind of came in late, so she wasn't there, but I don't know who everyone else was that was there that didn't get their rockets, but they had the supply list, so they should have been able to kind of check it out on their own.
Okay, then we won't go through the parts there for sure. As long as we have those parts that are mentioned on the screen there. Which teams were they? You did receive the kit, correct? The two schools?
No, I think
Like,
everybody has their kits now.
Okay.
Yeah, everyone's
Right.
everyone's set now.
Okay, I won't go through the parts then until we have a surprise that part. Next, please.
Yep. All right. Skip that one. So just a quick, again, on the website, we have the alignment guide, but we have copies of the handbook and the presentation. Recordings will also be posted there as we get past. So. Can't remember who did this one last time. Was that Sean?
No, Frank covered this one last time, I believe.
I can do it again.
Yeah.
High power rocketry has been around for a long time. Was in the Scientific American article in 1957. The design, propellants, and the launching techniques of high power rockets. Rocket Manual for Amateurs from 1960. Homer Hickam, Rocket Boys, if you've ever seen the movie, it's a very good movie. Then we have the National Organization of Regulation. It's the NAR, which is the National Association of Rocketry. And we have the Tripoli Rocketry Association, TRA. Those are the two main organizations that they're allowed to fly high power rockets at a certain altitude. The first amateur high power rocket went to space in 2004, went 72 miles up. The University of Southern California sets the world record in 2017, highest altitude that a student launched the rocket to 144,000 feet at apogee. Next, please. And all these launches are not done by, in your backyard. It has to be governed by the FAA, surrounding airports, and governmental agencies. And this here is the Todd Ward Center that we will be attending for the launch weekend. And these are some of the rockets that were built by some of the students a couple years back. And this is Rocketry 101, single deploy flight profile. This is what you'll be doing on your level 1 flight. Of course, we have the launch. We have a power ascent as the rocket ascends up. And after the motor burns out, we have a coasting phase. And as the rocket reaches apogee, and just right after apogee, the ejection charge deploys the parachute on the rocket, and the rocket slowly descends, and you get the recovery. Hopefully, should. Okay, this is a dual deploy flight profile. This is what's all going to be done during the launch weekend at the competition in April. We have the same scenario, except there's a couple stages. Of course, we have the power ascent. We have the coast ascent, which is the inertia after the motor burns out, rocket reaches apogee. And just after the rocket reaches apogee, or after apogee, the ejection is deployed. The drogue chute, the smaller chute. This allows the rocket to come down a little quicker and won't drift as far as if you would have deployed the main at the top. And of course, the rocket is equipped with your altimeters and electronics, and you have a program to deploy a main at a specific altitude so it doesn't drift so far. So you can see as the drogue has a slow descent of a certain rate, and your main deployment can happen any time above 300 feet. So your rocket doesn't drift so far, so the bigger canopy of the parachute deploys, and you get to recover your rocket, supposedly not so far away. These are the two differences between a single deploy chute on the left and a dual deploy on the right. These are the competition flight profiles this year. The very first one on the left is the gateway competition. It's just a standard flight ascent. Of course, we have the power boost and we have the coast, and we pull out the laundry at apogee, which is the drogue chute. And whenever the user programs the main to come out, anywhere between 700, 600, 500, 400 feet, whatever kind of weather conditions it is, deploy the main chute, and recovery happens after that. And of course, in the middle one, we have the Moon Challenge. Moon Challenge has a set altitude, which you can see, to acquire. And they have specific motors to use. I believe they have 2 motors for each model of rocket that they pick. Of course, we have the same scenario, apogee at the top, and they're going to be deploying a lander at the same time at apogee, along with the drogue chute. And the lander must have a parachute on it, and it must stick the landing with a GPS tracker on it. And as the rest of the rocket, the booster and sustainer descents, the main comes out at a specific altitude, either 6, 7, 500, 400, 300 feet. So it doesn't drift so far. And the far right, we have the Mars competition. Same scenario of the profile flight. We have a drogue at the top, and they get to deploy a drone at apogee, and the drone must parachute down to a specific altitude by law by the FAA, 400 feet. The chute can release from the drone, and the drone must come under operation and land on a specific target that's going to be on the landing field. And the rest of the rocket, the sustainer, the payload section, and the booster will deploy at a specific altitude, either 700, 600, 500, or 300 feet from the ground, so it doesn't drift so far. Note that all 3 rockets, they all must be equipped with GPS locating devices, including the landers and the rockets itself. All of them, including the gateway, must have a some kind of a GPS or some kind of audible locating device, so you can easily find the rocket. Here we have the structures of a rocket, typical high power rocket. The top rocket shows the booster section and the sustainer section and the nose cone. And each part of the rocket has an aft and a forward. With the rocket all together, the aft is towards where the fins are, and the forward is where the nose cone is. And during this build, we may specifically ask a certain part of the rocket, the aft end of the booster, or the forward part of the booster, which does not include the nose cone. So each component of the rocket has an aft and a forward part that we'll be referring you to during the build. And you can see kind of a skeleton profile between the middle and the bottom one there, where it shows the motor mount tube, all the recovery harnesses, and the parachute, and the coupler, which holds the booster and the sustainer together. Next slide, please. Aaron.
All right. And just wanted to ask, after the single and dual deploy, which are we doing with our kit? Just ready to use one or two on your video so I can see single or dual deploy with this kit. What do you guys think?
A single?
Single, yes. Because you only have one parachute with you. So you'll be just deploying one parachute and coming right down. The dual deploy is for your competition rockets. So it sounds like everyone has RockSim installed. So I'm just going to go through showing you the tour of the program. I'm going to take over the screen share right here. So hopefully you guys could see this. So there's 6 tabs up here that we'll be going through. You won't be using this one much, that you can change like the settings of how it's simulated, like this center of pressure. There's different ways to calculate that. I would just leave that as is. We're doing one stage. Multiple stages means multiple motors, one after another, and we're definitely not doing that. That's fun to do, but that's not in scope of FNL. The second tab here, this is what we'll be using the most. Once you import the kit that we'll be doing later on, all the parts will show here. And then such as like you add a nose cone. There's a database of parts that you'll pick from, and lock precision, as Frank mentioned, they do have lock precision parts in here. So we'll be going through and checking that our parts match the dimensions of the parts in front of you. But just to throw something on. So nose cone would be like that, and then obviously you can change the length, diameter, like that, or database, the part number, the shoulder, that's just how long this shoulder is, if you can see my mouse. Mass override, this is something we may use. It's good to try not to use it. What mass override does, it's basically you don't trust the mass that it's calculating based on the parameters you put in. So like right now it's saying this nose cone is a polystyrene plastic hollow with a thickness of 0.8 of an inch, and it calculates it to be this much, but when you go to weigh your part, it may be a little different. So if you want to be very precise, accurate, if you put a custom weight in here, say it's like 50 ounces or so, it'll turn the mass to override on there. But for now, we'll keep that off. And then when we go back to the main screen, there's a system level mass override. This one we definitely don't use. This is for like after you've simulated your rocket, you've built everything and you're comparing it and you're ready to fly, and you go to find the actual center of gravity on your fully loaded rocket and measure it, and it's a little bit off. This is what you would do. You would put the actual inches for the system level as like a override, but that's not a simulation tool that you should be using in the design phase. That's like a day of flight thing. So make sure to keep this off. That can screw up your simulation real bad. So third tab, mass override, keep that off. coefficient of drag, we don't really modify it, but if you want to get into the aerodynamic details, you can put in custom CVs from the manufacturer of certain parts. And then simulations, we'll definitely be using this. This is once you have a nose cone and fins in and a motor in the simulation, you would go up here to prepare for launch. And it's saying I don't have the parts yet, but it would go through a few windows of preparation, and then it would give you the results of the flight here, and we would use that to tweak our design. So we'll be doing multiple of these throughout the workshop, but that's the initial overview. I think the next time we do RockSim, it'll be importing the model from a website. So back to the slides.
Yep. Actually, that was leading right into the downloading the model.
Okay. So for the model, there is a website called rocketreviews.com. Oh yeah, I went over that already. So Rob will put this in the chat if you could go ahead and follow that. Rocket Reviews, it's like a database of user uploads or manufacturer uploads of different models. But for us, we'll be using this search function to find the caliber ISP. So once we click through, we'll be sorting by the manufacturer and then looking for that, downloading the file, and then opening it in RockSim. So I'll go through that on my screen. And if you guys could try to follow along if you can, this is useful for your competition rocket as you're trying to start or try other kits or other rockets you may build. So you come up with this. So in the search lock precision. Actually, it's lock last precision, and then go down to where it says caliber ISP. That's the one we sent you guys, and then let it bring up the results. And then there should only be one result. Is everyone following so far? Okay, that's good. So go ahead and click on that. And then there's the download link. It's the .rkt file you want. So save that somewhere. Download it a bunch of times. So labels -3. So I think RockSim now allows you to open it from double clicking. I'm on a Mac. It may be different. If it doesn't, then you'll have to go through like I'll open.
Oh, what do I say? I don't have that yet.
Excuse me. One of our members is having trouble finding the correct file.
Okay. Were you able to open the first link?
Yeah.
No, I just need the website to actually get to it. I didn't.
You were on the website.
I was.
Yeah.
It should be in the chat. If you look at the Zoom chat, it's rocketreviews.com/rocksim-library.html. Are you able to see that?
Say that link again, Aaron.
Yeah. Drop again.
There it is, it's on the chat.
Oh, yeah, Rob said it. Thank you, Rob. Are you able to see the web link in the chat now? I'm gonna take your silence as a yes. So let me know. Okay. Sorry, repeat it. How do we? And then I didn't hear the rest.
Okay. Now what?
Oh, you got it?
I clicked it. I am to this part now.
Okay.
Library.
So search LOC capital/precision, and then you should see this result under for caliber. I can type that in again.
Yep.
It'll bring up a bunch, and then just go down to caliber. But choose that, and then it'll show it in the results table. Do you see caliber ISP there? You're on mute.
Okay. We're good.
Okay.
Here we go. Thank you.
Yeah, no problem. Yeah, so if you got it downloaded, you should be seeing this, and go ahead and navigate to the second tab, Rocket Design Components. And if you click through these, it'll highlight the part below. As Frank mentioned before, this is your sustainer tube. They call it the payload section airframe tube, but it's your sustainer tube. And then this is your booster tube, also called the main airframe. And then you got your fin and all the good stuff, the motor mount feed, and rings that you'll be installing, parachute. And then here just to show you that there's some sample simulations that it already showed. The ones we'll be focusing on for you guys, the safety values, is this velocity at launch guide departure. That's how fast it's going off the rail on the launch pad, and it should be at least 52 feet per second. So like this one is pretty close, pretty slow, but all the rest are high enough. And there should be a velocity at landing to see. I don't see that. So you could add more values by going up to your RockSim preferences and simulation summary. And then you can add it should be velocity landing. Okay, maybe it's not here. No, that one out. But that one tells you how well sized your parachute is. Since you guys already have your parachute, that's not as big a deal. It's designed to slow it down to the right speed, but for your challenge rockets, that's where you would tweak your parachute. So I think that's it for this section. Let's switch back to the slides. Frank?
I am here. Okay, rocket build. You had to pre-fit check everything on your rocket, because sometimes the laser machine gets in the way. Shipping will maybe distort some of your tubes for some reason. So we're gonna do a dry fit of your rocket. the main rule here is always dry fit every part of your rocket before you ever apply epoxy, because this epoxy that you're going to be using sets up. It's a 5-minute epoxy. It sets up in 2 minutes, and it's hard to remove after that and wipe it clean if something doesn't fit. So we have to dry fit each part of the rocket. So let's see here. Of course, do not oversand your parts because we don't want the parts loose. Sand them to the point where the parts kind of fit together snugly, not where you have to really force it a lot, but as long as it fits on there snug and doesn't wiggle a lot. Let's see if we can, we have to dry fit the center rings, the coupler bulk plate, the motor mount tube, the airframe, the fins, and the nose cone. So what we're going to do first here, what's the next slide? There we go. What I want you to do first is take your 3 motor mount rings that you have. One has one has 1 hole in it, 1 small little hole, 1 big hole in it. And if you have your pencil or a marker, I want you to write on there forward, FWD. Then
And the side doesn't matter either, so just write it on any side.
And the next one has no holes in it except for the big 38mm centering hole. Right middle or mid, MID. And I prefer you write on one side, not both, just so we can reference when you're gluing these up to the motor tube. And your third ring is the aft, AFT. It should have 2 small holes on each side and a 38mm in the center. Once you have those parts identified, grab your motor mount tube. Should be a short tube, not your airframe tube, but your motor mount tube. Should be a 38mm. And I want you to take one of your rings, preferably the middle or the forward ring, or all 3 of them, and see how they fit. But before you even try and fit them on, I want you to take your sandpaper and sand your whole motor mount tube. There's a glassine which is on the tube. It's like a fat, kind of a waxy finish on it. We want you to sand that off so your epoxy adheres with your parts as you apply the epoxy. The glassine is put on there during manufacturing of the tube. So just sand it lightly. Don't sand it to where your tube is fuzzy. Just lightly sand it and rough it up. And then every time you sand it, let's see how your motor mount tubes centering rings slide on. Just slide on the whole length and be snug. They can be somewhat tight, but just as long as you get on there and you have some of that glassine, sand it a little bit so it can adhere to your motor mount centering ring. Your hands may be a little dry because it's wintertime. If you want to put on a glove to grab the sandpaper, and the back of the sandpaper will grab your the glove real good to sand it. You can go up and down like this, or doing a circular motion, whatever's easier for you to do to handle the sandpaper, so you sand it generously. And every time you sand it, I want you to do a dry fit of all rings. Make sure they're on there snug, not too loose, not too tight. And if you still can't get the motor mount ring onto the tube after sanding the tube generously, you may have to sand in the center of the motor mount ring. And that would involve the sandpaper in between your fingers and the centering ring. If you want to sand it by hand like this, Or you can take your craft stick, wrap sandpaper around it, and sand it like that. You get a stiffer, more rigid object that'll sand the center of the internal ring of that motor mount too, motor centering ring. And make sure every time you sand it, do another check. Make sure it's not too loose. Every time you sand the whole radius of that tube, you're sanding actually the double of the radius. So don't sand too much. Don't go around 2 or 3 times. Just go around once and check it. Make sure it's a nice snug fit.
For getting it on too, it does help when you're about to come onto it is to twist to get it on. Right? So don't just try to jam it straight on, but twist as you're going.
Yeah, try not to mushroom the end of the tube. They already have their centering ring fitting snugly onto their motor mount tube. I need to see parts and people.
We don't have our parts quite on yet.
Okay. I don't want to work ahead, and I don't want anybody working ahead of me. Bob has it. Sean looks good. Justin, pretty good. Yep. Excellent.
Abigail looks good.
Abigail, yep. Abigail, thank you.
If this on.
The Scott team, I'm going to call you the Montana Tech team. Yeah. How's that?
Yep, sounds good.
All right, MTT. All right. Nick, you look good. Aurora, we're waiting. That's okay. Be patient. Alexa, how you doing? Good. Thank you. Yeah, if you're having a hard time putting it on, you may want to sand a little more, especially if it's the aft ring that you're using. We want that kind of generously looser, the aft ring. It can be snug, but it can be, the aft ring can be the loosest if you have, if anything you want to sand. Well, thank you, Daniel. All right, Aurora, thank you. Oh, you got one more to do.
Yep.
All right. Yeah, perfect. Excellent. Good job. Yeah, it looks like everybody has their centering rings fitted on their motor mount too. Excellent job, everyone. I need a slide. Thank you. Okay, what we're going to do is take the forward centering ring. I'm going to turn on this camera too.
I want to know if it's.
We're going to take the forward centering ring that has one hole in it. And we're gonna grab the smaller eye bolt. It has one nut and one washer on it.
We got two each.
If you have two washers, that's great. Just put a washer on first if you have if you have two washers. Okay, if you got two washers, put the washer on first. If you only have one washer, put the eye bolt in. You may have to screw it on just about because it's kind of a tight fit. It's fine. And put if you have another washer, you can put it on the eye bolt side. And it doesn't matter which way the lettering is on this one. You put it. And then once you have the eye bolt all the way in, put the washer on, and then put your nut on. And if you have you can kind of pinch the nut and turn it with a craft stick to tighten it up. You have to, tighten as tight as you can. Or if you got a handy pliers, use that. Because what we're going to end up doing later on, we're going to be putting a little epoxy on end of that nut and that thread just to secure that nut and thread together, almost acting as a Loctite. So we're not going to do that now, just to let you know. And you're going to ask me which way should we have that eye? Make it straight with the ring. The flatness of the ring should go parallel with the surface of the ring. Because since this is the forward motor mount ring, it's good practice to keep it there sometimes. Because if you have it turned like this, and it's a bigger ring, and you have a bigger motor that goes through it, it's going to hit that eye bolt possibly. So we want to keep it like this for now. If you have two washers, put it on the top side and the bottom side. If you only have one, just use it where you tighten down the nut. Okay, good job. Good job, Sean. Sean, you're moving ahead.
Oh.
Okay, next slide. Does everybody have their eye bolts on? Laura is working on it. Justin, you got it. Nick, how you doing? Thank you. That's better. Thank you for that shot. Okay, thank you, Daniel. Aurora, you got yours. MTT, you're good. All right, thank you, Abigail. But you have that on the wrong way, though. You can pull that off. You can pull it off that motor tube.
No, I put the washer on first, like an idiot.
Yeah, you're good. Just pull it off the motor tube. We're not that far yet.
That's probably it.
Yep. Because we gotta do some. We have to do some measuring before we put the motor mount ring onto the tube. Anyways, unless you guys got good measurement eyes. Okay, everybody has their eye bolt on their forward motor mount ring. Great. Okay, next we're going to take the bulk plate, which has one small hole in the middle, like this, called a bulk plate. And we're gonna take our big eye bolt, or bigger eye bolt, and you should have a nut and 2 washers complete, correct? So leave one washer on, connect to the eye bolt. Take your eye bolt and put it through the center of that hole. Take your last flat washer and slide it on the threaded side. And take your nut and tighten it up against your eye bolt and the bulk plate, just like so. If you have pliers and a screwdriver, you can turn it as tight as you want. They're not going to crush it. But we're going to do the same thing here later. When we have the epoxy out, we're going to put a little epoxy between the nut and the thread, so it acts like a Loctite. So this part here is going to hold the recovery system, the harnesses. So we don't want this spinning at all. So we want this tight, and we're going to seal it with some epoxy on there so it doesn't spin off. And it should look just like that picture you see on your screen. Many pictures. And the orientation of it doesn't matter. Okay, this is kind of important.
I'm assuming these big ones right now.
I have to get mine out.
Yeah, I feel that's the one volt.
Someone's got their mic on. You got a hot mic, somebody? Unless you have a question, we'd love to hear from you. Okay, if you look at the next slide on your screen, dry fit the
Excuse us, and their kits, they only have one nut for the bulk plate for the top. They have a nut, then a washer, but not another nut. Is that right?
You only need one nut.
Okay.
Some people might have 2 nuts, but if you only have one, just put it on the back side. If you have 2 nuts, you can put one on towards the eye, and you put one on the back. Doesn't really matter. Sean, you got 2 or 1 nut? Yep.
1.
Oh, you 1, okay. You might have extra parts, but just follow our mainstream, and it should work out. Okay, what I want you to do next is take your coupler, and if you haven't found your coupler, it's always hiding inside your sustainer tube, way deep inside. If you go, I don't have a coupler, it's inside there. Look very hard, feel, go in there and grab it out of there if you don't have one. And we're going to pre-fit your bulk plate into your coupler, and it's probably going to be maybe loose a little bit. It might fall out, and if it's real snug, put it in at a 45-degree angle like this, and snap it in if you have to. Stay on the side of the bulk plate for proper fit. If it's too tight. We don't want it super tight, because if it's too tight, it'll warp your coupler and it won't fit inside. It won't fit. These won't couple together. It'll be too tight. But if it's a good snug fit and it kind of snaps in, you're good to go. This is just a pre-fit. And what we want you to do is put and place that, get an idea where that bulk plate has to be. And as you see on the slide, it says 1/4 inch from the end of the coupler. That way, That way, when it comes time to epoxy this permanently, we put a good fillet around this ball plate and the inside of the coupler. There's a very important integrity part which has a very pull point during flight when it deploys. Got to make sure you put a good layer of epoxy in there when it comes time to do that. And to read the ruler, your ruler is not dead-headed to the bottom of that. The zero is not at the end of the plastic. You got to look at that zero on the ruler to measure the distance between the beginning of your coupler to the depth that you have to be. So make sure that zero is at the part you need to measure. It's got to be at least a quarter inch to 3/16. You can almost eyeball it. We just do this for accuracy, I guess. We got to make sure that's recessed in there at least 3/16 to quarter inch. Next slide, please. Okay, the center ring should fit on the motor tube, which we went through. Excuse me. Mark the forward end of the motor tube, motor mount tube, an 1/8 inch to 3/16. So what we want to do is you want to take your measure, your ruler, and make sure to zero it out. Tiny, you shouldn't get clear ones. These are hard to see on a camera. I thought I had a colored one up here. And take your pencil and mark it 1/8 to 3/16. Mark your tube with your pencil and do a 180 and measure the same thing, either 3/16 or 1/8 inch from the edge of the motor mount tube. So when you put your motor mount ring on, you know it's level and straight, it's not wiggly and crooked. So what we're going to do, once you have that position marked, I want you to take your forward center ring and push it back a good inch or two back. Because the object of doing this is when we do apply the epoxy, we're going to apply the epoxy just below the line you made. So when we push it up and twist it, it makes a nice fillet around there. So back it off a couple inches like this for now.
I got a question. Are you going to release the slide later on?
Pardon me?
Are you going to release the slide after this meeting?
Yes, and they should be available on the website currently in the tips area.
Okay.
I'll send a link out to the chat.
Next slide, please.
Yeah.
Woo.
Right?
Okay, yep. Okay, next, we're going to take our mid ring, okay, and we're going to take our airframe. This is just an example so you get an idea on the measurement where this mid ring is supposed to go. Okay. This mid ring is supposed to go ahead of the fin slot once it's inside the airframe. So we want this motor mount ring even with the airframe. the edge of the motor mount ring, motor mount tube, equal with the airframe. And the mid ring should be ahead, just ahead of that fin slot. It's just an idea I'm giving you how that's supposed to be in there when we permanently apply epoxy. But there's another method that is pretty accurate, so just giving you the idea. So what I want you to do, take your ruler. Don't forget to use the 0 on it. Of course, this is your forward that we're going to be mounting up here. This is your aft end of your motor tube, okay? Each part, like I said before, earlier, that we're establishing a rocket part. This part's going to be the aft, that's going to be the forward. So what I want you to do is measure from the aft end of this motor tube 5 1/4 inches. And I want you to draw a line on one spot where it says 5 1/4 on your ruler. Mark it. Go 180 on the other side. Do the same thing. Mark 5 1/4 as it shows on the slide. Excuse me. Make sure you're using that 0 at the end of your tube. Okay, once you establish that 5 1/4, I want you to take your mid, where you have it written mid, I want you to face it towards the aft end of that tube, so you know what direction I want you to go with this. I want you to mark slide your mid tube down to that line you made, okay? And I want you to take your pencil and draw a line on the forward part of that motor mount tube, all the way around. So you should have a 1/4 inch line, reference line, where your mid centering ring goes. After you establish that reference mark, I want you to take your mid motor mount ring and push it back an inch or 2 back from that mark you made. Same thing with the forward centering forward ring. I want you to push it back an inch or 2 from the mark you made. Everybody got that? Everybody cool? All right, thank you. Thank you, Nick. Yes, yes, and yes. Great. Oh, I told you to slide these back, didn't I? You can position, I see they got a little reference here just to make sure you have the distance right on these rings. I don't know why, but the measurements that we instruct you, this should come out in the end perfectly. So take your mid ring and put it in the position that you made the lines on, and take your fin that you have. There you go. You should have a good 1/4 inch, overhang on the aft end of that motor tube once you put your aft ring on, and to where your mid centering ring is positioned. Right. Should be positioned just like this. You should have a good 1/4 inch on the end of your motor mount tube, on the aft end. Just for a reference. Now your fins, all 4 of your fins should fit inside the fin slots of your airframe, okay? Some might be tough, so I want to make sure that they fit in there kind of snug. Some you may have to, if it's too tight, take your fin at a 45-degree angle like this and put the corner in and then force it in and snap it in. You won't crush the tube too badly, but it'll go in. But if it doesn't go in, you can sand your fin slots by using your craft stick and a piece of sandpaper. And if it's perfectly inside that slot, you can sand it.
A small pro tip here is, when you do that 45 one way to kind of get it jammed in, okay, take it and then turn it the other way and then jam it the other way, just that it gives the top end a little bit more clearance, right?
Well, if you are sanding your slots, don't sand too much. Just make sure the fin is in there snug. It is a good fit. They cut their fins too tight, but it should fit in there snug. There's, not so much wiggle. It's just another pre-fit scenario. You got all fins that are fitting your slots. You can pull them all back up and put your fins to the side. Okay. Next slide, please, Rob. Who's got control, Connie or Rob?
Rob does.
Okay. Here we go. Okay, the epoxy. If you have not opened your epoxy already, I need you to do that now. Each container, the epoxy and the hardener and the resin, the 2-part epoxy, it's 1-to-1 ratio. You got to put equal resin and equal hardener when you mix it together.
Break out the gloves.
Yep. Please put your gloves on. And if you get epoxy on parts you're not supposed to put them on, I would suggest maybe crack open an alcohol pack if you want to. But of course, the alcohol is going to dry up on you. By the time you find something you have to wipe, or if you have rubbing alcohol available, that works the best. You have rubbing alcohol, that works great. But we couldn't ship this to you because it's kind of a DOT thing. So we had to mail a little alcohol wipes. So we have this two-part epoxy. It's a fast-drying epoxy. It hardens very well. This is only 5 minutes. They make 30-minute, which I have right here, a 30-minute. They make an hour one. The longer it cures, the stronger the epoxy is. And the 5-minute epoxy doesn't mean that you put a rocket together, wait 5 minutes to apply the rocket. No, don't do that. It takes 18 to 24 hours for the epoxy to cure. So there's two differences here. Setting, when it sets up, that means it's not workable when you mix it. And curable means that it has totally cured and hardened and has adhered to the object that you applied the epoxy to. There's various types of materials and strength. We have JB weld, which can bond plastic to metallic bonding. It adheres very well. It bonds okay. It'll hold it. You can add silica additive to epoxy and mix it, and it makes it real stiff, almost like and it comes like an Elmer's glue color, but it gets real stiff and doesn't run as much. And I explained about the 5-minute epoxy. It sets very quickly. We use it in this build because it takes time to build a rocket. If you're going to do a competition rocket, it's going to take you a good probably 15, 20 minutes, even half hour sometimes for epoxy that you're going to use, like 30-minute epoxy, a good 15 to 20 minutes for it to set up, not actually, bond until the 18, 24 hours is up, but it's very time consuming, but it's very good bonding when you use a longer bonding curing time. And as you can see in the picture to the right, that's a 1-to-1 ratio. That's about, I don't know, was it a nickel or a quarter size? What we're going to do here is probably pour this into your plastic cup like this, and we're see if you can take both your hands and squeeze it in there for 2 seconds. What we're going to go through now is the epoxy fillets that we use, that I was explaining to you on the ball plate before. We sunk that in, good 3/16 of an inch. And of course, we're going to be doing this on your fins. Once the fins are installed, you have to create a strong bond between the two surfaces, the fin and the airframe. And we usually put tape down to tape any runs or messes that we put down. So we have a 1/4 inch gap between the fin and the airframe on each side of the tape that is applied. And we kind of create a valley, which you can see in the picture lower right hand side, which is indicated in the color of yellow, which is the epoxy. And we kind of fill that void in, that gutter, with some epoxy, so it bonds between the fin and the airframe. Always wear gloves, of course, prior to mixing the epoxy. Work quickly. Just make the certain amount that you need for that application. You get epoxy in your skin or unwanted surfaces using rubbing alcohol to remove any residue. Especially if you're going to do your, let's say, your bulk plate and your coupler. Try not to get any epoxy outside of this coupler, because it will not fit into your airframe. So if you see some epoxy in there, wipe it clean with your alcohol. Otherwise, you're going to be sanding. Another hint: once the epoxy is cured, it is very difficult to sand. It kind of melts more or less. So you want to remove most of the epoxy when it's in the curing process, so it removes easily. Next, please. All right, here's the fun part. Okay, we dry fit all the parts, all the centering rings for your motor tube. We want you to put your gloves on. That means your right hand and your left hand. I guarantee you'll get epoxy on one or the other if you're not wearing the glove. Okay, what we're gonna do, we're gonna open up our epoxy.
That's it.
He's just doing it right now.
Okay.
And there should be a black cap inside the other cap. I want you to take your knife or your screwdriver and pop it open, or you can take your finger. I don't want you to get your fingers all full of epoxy. Take some kind of tool like either your knife or your screwdriver and pop it off and throw that cap away. And if you don't have a garbage by you, use a cup. Just throw your little parts in there. The cap's going to be on each container. Unscrew it, pull the black cap off, or a red cap or green cap, whatever you have. Pull it off. That's just for shipping purposes. And then once you've done that, I want you to take your knife and cut the tip of the pour nozzle. I want you to cut just above that rib that you see. That rib is actually for the cap to put back on to snap it on so it stays on. So just cut above that rib. Just above it. Close to it, just above it.
So you want a large diameter hole, exit hole?
It's just above the rib. That's the same, that's the size you get, yep.
So that's towards the bottom. Yeah.
Yep. There should be a little rib on there, right? A little crease right there? A little rib?
Yeah, and about a 1/4 inch opening. When we took the top off, there's about an 1/8 inch opening.
Yep. Good. Well, maybe get my measuring tape out.
Don't forget to slide the mid-ring back down a couple inches.
Yeah, we didn't tell them to apply epoxy yet. Yeah, it's a good 1/4 inch opening, just under it. Everybody have their glue cut open yet? Oh, I see. Sean is still working on it. Put your gloves on, Sean. I know. Me too.
Yeah. I'm afraid if you do it too small, it's gonna close up at the edge and then it's like.
And when you cut the tip of that pour nozzle, just above the rib, cut it. Don't cut the rib out. Just cut above it. Does everybody have their epoxy ready to go and ready to pour, ready to mix? I see thumbs up. Okay, Nick, got that. Justin, how you doing? Thank you. Laura, okay. Abigail, thank you. Okay, I see the class got their thumbs up. Thank you. All right, what we're gonna do, we're gonna end up gluing, applying epoxy to the motor mount tube. So I wanna make sure that you have your motor mount tube orientated properly. Okay, this is your forward that has your, oops. This is your forward motor mount ring, which should be pushed back about 2 inches or so from your forward part of your tube where you made your mark, 3/16 of an inch. And then your mid ring should be back towards the aft part of the marks you made. Okay. So your mark is here for the mid tube. Can't see my camera. There, I can see it. Here's your mid ring. Here's your mark you made for your mid ring. Here's your forward ring with your high bolt up. Okay. And your forward ring is pushed down a couple inches from the mark you made. Okay. Okay. I want you to take your epoxy. Now, I've been doing this for a few years. I usually take both of them in my hand like this and squeeze it inside there. You can take one at a time if you want, depends how strong you are. And what I want you to do when that epoxy hits the bottom of the cup, count 2 seconds. 1, 2, and stop. As soon as the epoxy hits the bottom of the cup. Excellent. You can do that one at a time or both at the same time. Start mixing your epoxy with your craft stick. Mix it up real good. Sean, where are you at? Oh, there you are. Okay. I want you to apply. This is your mid ring right here. I want you to apply epoxy right between the lines you made. I want you to apply epoxy on there. All the way around. A pretty good generous amount, you know. Don't make it too sloppy, and we're not finger painting. Let's do this quickly because that stuff sets up, you'll find out. And once you get that all the way around the tube, I want you to push your mid ring up and stop at the top line like that. Very important. Once you push that mid ring up, do not get any epoxy on the back side or the aft end of that motor mount ring, because later on we need to put a fin there, okay? And we don't want the fin to be up like that with epoxy in there. We just want the epoxy on this side of the mid ring. Okay, now when you get that done, I want you to flip the tube like this, because you lose, or actually epoxy loses into gravity. Okay, it'll drip, it'll run. So you got to make sure that your epoxy runs onto the part that you want to adhere. Okay, because if you keep it like this, it's going to run, drip down, be uneven all over. So you want to keep it like this. Once you've keep an eye on that. So as you push that ring up, you should have a nice fillet around that ring and the motor mount tube. Sean, what are you doing there? Show everybody. Okay. And once you've established that, keep an eye on that epoxy that has that fillet on there. I want you to do the same thing on the forward ring. I want you to apply epoxy within that 3/16 of an inch right on the edge of that tube. And I want you to push this up too. Or you can put it back. You can put it back behind that line. So when you push it up, you get a nice fillet. Okay? And then tip your tube up like this. Oops, like this. So none of the epoxy runs left or right, as long as it lays flat onto the motor mount tube and the motor mount ring. And keep your lay your motor mount tube off to the side, vertical like this, so the epoxy stays where we want it to stay. If your epoxy starts getting gummy and it gets kind of spider webby, throw the whole thing out, start a new batch. And of course, if you're halfway in between the applying the epoxy and your epoxy sets up too much, don't mix as much. Mix what you need. Nick, what do you got? I want you guys to pull off this aft ring you have on there. Pull that off. set that aft ring to the side. Thank you. I don't want to confuse anybody. So by the time we apply the epoxy, we should only have 2 rings on. One should be 5 1/4 inches from the aft end of this motor tube. The other one should be at least 1/8 to 3/16 recess into the forward part of this motor mount tube. And keep your motor mount tube vertical. Just like that. Now, if you have some epoxy left over, but we'll be doing this. What's the next slide, Rob? Okay. We do put that on. Okay. We'll go back to the, or show everybody on the screen. Leave a cameo, everyone. I need the audience.
William, how's the build going for you?
Oh, I'm just applying the epoxy right now.
Make sure, you know, that the epoxy doesn't run. It'll run all over the place. And make sure the epoxy does not run anywhere on the aft end of that ring. So when we put the fin on, there's nothing in the way here that we can have flat contact with that fin. It's called through the wall fin construction. And we'll explain that once we describe the fin characteristics. Can you show the group, Rob? Thank you. Now that epoxy should set up or not run in like 2 to 3 minutes. And if you have any more epoxy left over, why don't you mix a small batch? And I want you to apply epoxy around this forward high bolt nut and thread. Just put it between the nut and the thread just to lock it. And do the same thing with the bulk plate nut in recovery eye. And do the same thing. Put the epoxy between the nut and the thread. And of course, keep the epoxy from running. Alexa, how you doing? Good? Thank you. Jacob, how's it going? Thank you. Daniel looks good. Rob is hungry. So am I. We're all hungry, right?
I couldn't help myself.
All the time, I know. MTT, okay? Hey, Rob, do we go with the recovery harness inside the? Do we mount this tube in the airframe yet? Or is that tomorrow? I'd like to do it. Aaron talking on the next slide, I'm thinking. You see the picture on your screen right now? That's the way your tube should be looking without. You should have a nice fillet around the forward round tube and the motor mount ring. Next slide, Rob. There shows an example of the putting a little epoxy on the nut and the thread and the forward ring. We're going to do the same thing on the not going.
Yeah.
Oh, okay.
Sorry, my computer's freezing up a little bit.
That was pretty quick.
Yeah, you guys
All right.
did pretty well tonight.
Well, give me a picture of the crowd. I don't see how far they are. Maybe we can get one more little tiny procedure done here.
Yeah.
Does everybody have their rings fillets, epoxy and everything? Let me see. Yep. Okay. We could do one more move here before we leave tonight. Grab your recovery strap. It should be black, green, purple, pink, green, whatever.
Otherwise, Frank, did you want to try to get the coupler done tonight, or
Oh, yeah, I suppose we could.
we could always, sneak ahead if you want to get that step out of the way.
I would get the set away. As long as they have you guys got your gloves on yet, right? Everybody has their gloves on? Okay, that'd be cool. Good idea, Rob.
Since you guys are doing so well on time.
Yep. Okay, I want you to mix some more epoxy like you did before. As soon as your epoxy hits the bottom of the cup, don't use the same cup. Use a fresh cup. Don't try and remix some fresh epoxy into old epoxy. Use a new cup, new stick. Matter of fact, if you take your alcohol or even just a wipe, and if you want to wipe your stick off before it even starts getting sticky, you can reuse your stick again. It's no big deal, but you can't use your stick once there's a clump of epoxy setting up on it. Anyways, I want you to mix some more epoxy like you did before. When the epoxy hits the bottom of the cup, 2 seconds, 1, 2 of both each epoxy or the hardener and the resin. Mix it up real good. And what I want you to do is take your coupler and smear some epoxy right on the edge right on the edge on the inside of the coupler. Try not to get any epoxy on the outside of the coupler. Once you've established enough epoxy around the radius of the coupler, I want you to take your bulk plate and push it in that 3/16 to a 1/4 inch. You can eyeball it. And what you'll have to do, since it's kind of a loose bulk plate, you may have to take your hand and hold it there for that 2 minutes before the epoxy sets up. And when you hold it like this, because epoxy is going to run inside the tube. You want to make sure it runs up against the bulk plate. So periodically check it, make sure your bulk plate is straight. Make sure your bulk plate is straight and even, the 3/16 to a 1/4 inch inside, recessed inside the coupler, and hold your coupler up so the epoxy runs down into the bulk plate and adhere to the coupler. And you're gonna have to probably maybe squeeze it because it will move on you. I guarantee it. If you don't watch it and look at it, it'll move on you. So you gotta hold it for a good 2 minutes like this. And then once that 2 minutes is up and it has set for you, you can take your cup like this, and you can set it on the table with a cup like this once the epoxy has set up, so your bulk plate won't move.
One thing to keep in mind too is in the past, we've had these fail where this gets released from the coupler. So make sure that you're being a little liberal with how much epoxy you're putting on this thing.
Well, the liberal part is actually the this part here. Later on, we'll be applying fillets all our parts to make it
Oh, okay,
structurally,
got it.
right?
Gotcha.
That's the part that you got to do.
Yeah.
That's a load point right here when this gets pulled. During flight, this part here deploys at apogee, and it gets yanked pretty hard. So you wanna, we'll cover that tomorrow once we get a nice fillet on there.
Well, that's the next slide. If part of this step, if you wanted to clear through that.
There you go. Perfect. Thanks, Rob. Make sure to hold it. So I got 2 hands, 1 hand on it to hold it that 2 minutes so that epoxy kind of like sets up a little bit. You can lay it on its side, or like I say, you can lay it on a cup like this overnight, you know, on the table. As you can see in the drawing on the lower right hand side there, we'll be going over that later on, probably tomorrow. Put a nice fillet around that. I want to be on time tonight, Rob. Okay, now we're establishing a aft and a forward part of each rocket component. As you can tell, this is going to be the aft end of the coupler. This is going to be the forward end of the coupler. Same thing goes with the motor mount tube. This is the forward part of the motor tube. This is the aft end of the motor tube. Trying to get the crowd there, Ron? Thank you. Justin, you all set? Okay, excellent, thank you. When you're laying it down, lay it on its side more or less than on the, yeah, the epoxy's running around, thank you. See, William, how you doing? Excellent. Jacob, yep, excellent. Aurora, how you doing? Thank you. Oh, she even got a nice fillet on there too. Make sure there's no epoxy on the outside of that tube of the coupler. If there is, wipe it off. Okay. MTT. Thank you. Sean, thank you. Nick is patiently waiting for it to set. Abigail, good. Thank you. What school's on the split screen again?
You talking about it?
United
Yes.
Tribes, I think. Is that who you're talking about?
We're with United Tribes.
All right, thank you. You guys are so tiny. All right, looks like we got everything done. What we want to get done tonight. What time is tomorrow, Rob? 9 o'clock? 10 o'clock? What is it?
10 a.m. 10 a.m. Central.
Really? Okay.
I don't have any fear. You guys were doing so well today, and you guys were ahead of schedule.
So lay your parts to the side. Make sure you don't lose any screws, nuts, or bolts. And if you have those little tiny screws, nuts, and bolts, put them in a cup too, or put them on your paper plate. The reason for the paper plate, that's to put your refuge stuff when we get to the taping part, because that gets kind of messy. So save one of those plates for the messy part of your construction. You can take your gloves off if you want, and dispose of them. You're done with the epoxy. Put the caps back on each epoxy too, please.
All right, Sean, you've been showcasing them. What's the flavor?
Looks kind of spicy. What is that? Oh,
Grilled barbecue.
Yeah, grilled barbecue, but everything's in Chinese. Mm.
Looks as long
Yeah.
as ours.
Yeah. Grilled barbecue. Yeah, you guys are gonna be surprised on how much Chinese I've actually learned since I've been here. Yeah. Kind of impressive.
Anybody have any questions during this build or anything for tomorrow? Will everybody be here tomorrow, I hope?
Yeah.
Excellent. Thank you, Daniel. Yes.
I do have a question. I did not put it on yet. I must have missed it with the measurement. The aft section right here.
Yeah.
The measurement on that, was it to the where the fin was?
Yeah, the app you don't even have to put on. Just
We're
keep
not
it
putting
off.
that on. Okay, cool. I'm double checking.
Yep, the app stays off.
Didn't know if I'm missing anything. Cool. Everything else is. Thank you.
If anybody put their app on, you better take it off now. It's got to be laying off to the side, just like that picture showed.
Frank? Hello?
Hello.
How long will the workshop be tomorrow? Is it 6 or 8? We couldn't remember. Just 6.
We start at 10, we end at 6. So we usually
8 hours.
try and make it early.
10 till 6, but you guys have been moving quick, so.
Yep.
Thank
And
you.
there are some breaks in there. The schedule should have been mailed out, but it's also available on the website. And then with you guys having gotten a couple slides ahead, I'll redo the slide deck that's available for tonight. So it matches up. And then tomorrow's will be posted as well.
And if you got a job you have to be to and you can't complete the end of the construction, talk to me or Rob, and we can find something else for you to finish it, okay? But we don't want you dumping out there. But if you have to, you have to.
Life does happen.
That's right.
All right.
Justin, done.
I did want to give a reminder for a few people. Is that okay? Can I do that now?
Absolutely.
Most of you sent in your TRA or your NAR application. If you're already a member, I just need some type of a confirmation, maybe a picture of your card or something like that from TRA showing me what your membership number is. If you're not a member, we pay for your membership this year. And so that's why you're filling out your TRA or your NAR application so that I can send it in and pay for it for you. The reason we're saying TRA or NAR is depending on where you're living, you might actually be certifying with someone with NAR. And so maybe you prefer that. I don't need both applications. Some of you sent me both the TRA and the NAR. I just need to know which one. And that might be something that either your advisor or your mentor would know who you're going to be certifying with. Now, if you're not going to be certifying where you live, you could bring your rocket and you could certify in April with Frank. And I would need to know that as well. So that we have enough motors for you when you come. So if you sent me your TRA and your NAR application in that same email, if you could reply in there and just say, actually, can you pay for the NAR membership or can you pay for the TRA? If you don't know, talk to your advisor or your mentor. And if you don't know by the end of tomorrow, that's okay. Just email me and let me know eventually, because I want to, within the next week, I would like to pay for those memberships and get those out to whichever club you're going to go with. Does anybody have any questions about that?
I have a question. So I have a level 0 in the TRA. Do I have to pay extra to get my level 1?
No.
No.
Okay.
So did you pay for a membership last year because you were already on the team last year?
Oh, yes.
Okay, so you're a member, but you're not certified. And so as long as your membership is still good, when you certify, you don't have to pay extra. But if you could send me if you could send me a photo of either your confirmation email that you got when you became a member or a picture of your card, if you got a card, so that I can write your membership number in here, that would be helpful to me. Yeah. So, and so for the rest of you, if you sent me both, please let me know which one. And then there's 5 of you who have not sent me an application yet. If you could do that by tomorrow morning, that would be helpful. It's pretty quick to fill it out. When you're filling it out, you don't have to put in any payment information like a card number, but you do need to check which membership category you would be a part of. Like you're under 18 or you're between, it depends on if it's NAR or TRA, you're between 18 and 24 or whatever it might be. If you could check that so that I know how much I need to pay for your membership, that'd be great. Any questions?
Yeah,
you,
so if I'm NAR, then would the students be NAR?
So who do you certify with in your area? Are you guys Montana or North Dakota? I always forget.
North Dakota. We go with Tim Young.
Is he NAR?
I think he's NAR. I'm fairly certain. I'm fairly certain he's NAR. I know I'm NAR.
Frank, what do you think? Frank, should they all do NAR then?
Yeah, they can do NAR. That's no problem.
But
Okay,
if they want to certify in Wisconsin, would they go TRA?
Yes, but no. If you do it at our launch, we do have NAR people that can certify you. Yes.
so I guess it's your choice then.
Okay,
We'll have both people that are NAR and.
Tomorrow at
okay.
10 a.m. Yeah.
So
that's
just,
perfect.
Alexa, just let me know so I know who to pay for those memberships.
Go ahead and do NAR.
NAR, okay, got it. NAR for all three of them. Okay, got it. Thank you. That's it for me.
All right, bye.
Thank you, everyone. I'll see you tomorrow morning at 10.
Thank you.